DataWalk is a software platform that enables you to quickly and flexibly combine multiple internal and external sources into a single integrated data hub for sharing and visual analysis. DataWalk provides the capability to easily generate dynamic connections across distant siloed data sets for efficient investigations, flexible alerting, and for prototyping new analyses. In this demo, we will show how DataWalk can be used to quickly test various fraud hypotheses and to identify and investigate various types of fraud for insurance companies providing automobile insurance. We first see the Universe Viewer, which provides a simple visualization of all the data in the system, as well as any desired connections between these data sets. Each icon represents data from one or more sources. In this case, we've integrated VIN reports, claims data, insurance agreements, and information about vehicles, individuals, and customers. We've also loaded data about car repair shops, adjusters, and agents, as well as data from NIC B4WARN and ISO NetMap. Finally, we have loaded a data set of car values such that we can extract the make, model, and year of a car from the VIN and use that to automatically estimate the value of any car involved in a claim. At any time, we can select a set as our viewpoint, see underlying data, and see connected data in other sets. Note that the data model shown here is highly configurable and is specifically customized for each deployment. Creating a basic integrated view of siloed data such as this can typically be done in a few days and can be modified as desired. In this example, we have several hypotheses on potential fraud conditions, and we'd like to check historical data to see if these hypotheses may represent conditions of concern. With DataWalk, we can easily test these hypotheses without using either SQL queries or a programming language. For example, we'd like to see all claims that were filed more than 10 days after the loss date. With DataWalk, we can easily filter data to instantly find and then review such claims. Another example is to identify claims where the same phone number was referenced, but where the addresses were different. For this, we can instantly generate a private connection within the claims dataset, where we specify that we want records where the phone numbers match, but where the addresses do not match. We see that with DataWalk, we can create complex connections with ease. We can then instantly identify and review any suspicious claims with these characteristics. For our next example, we want to check involved party addresses against a list of commercial mail receiving agencies, or CMRAs. DataWalk provides the ability to easily integrate a new data source on the fly without interrupting system operation. In this case, we simply drag an Excel file of CMRAs on the DataWalk Universe Viewer. The system will automatically detect columns and their formats, and will create a data set into which additional data can be automatically ingested. Now we will use DataWalk's private connection to find involved party addresses that match CMRA addresses. First, we select the operation we will use, and then we select the right column and rule to create our visual query. We then instantly see how many matches we have, and we can of course view these matches in detail. We've seen that this private connection can be quickly created without either SQL querying or programming. Private connections are visible only to the user who created them and provide this user with a unique view, though if desired, these can also be converted to permanent connections which are available to all users of the system. In a last quick example, we will check another fraud hypothesis. Using our data set of car values, we can identify claims involving vehicles where the difference in values was at least 10x, and individuals involved in those accidents are involved in other claims. We set up a filter on the connection between claims and individuals and on the vehicles data set. And immediately we see several thousand suspicious claims which meet this rule. Since our capacity for reviewing claims is limited, we limit only the top 20% based on the claim value. And now we see the 450 highest value suspicious claims. We conclude that this condition is important to detect, so we immediately set an alert for this rule. Note that if you have appropriate permissions in DataWalk, you can instantly change or configure alerts without limitation. Now we will take a deeper dive to investigate suspicious claims related with rules we have previously generated. DataWalk can import alerts from other systems or can be used as an alerting system itself. In this case, here on the DataWalk Alerts dashboard, we see alerts generated by DataWalk with a score for each alert. We will start from the highest score alert triggered for an accident where the difference in value between vehicles involved was greater than 10x. We now explore this alert. We go to the DataWalk customer panel, where data from various insurer systems is presented on a single screen that's intended to provide all information needed in order to quickly disposition an alert. We see in the DataWalk customer profile that this customer is Kenneth Carter, a low-risk customer who lives in Mountain View, California. We see that he previously had a high-value claim, and this gives us reason to further explore, so we now proceed to investigate this case. And go to the Universe Viewer to see a 360-degree view of investigated objects. As the Universe Viewer provides a holistic view of aggregated data, now we use a different technique, network graph analysis, to look at our data from a micro perspective. At first glance, we see our customer Kenneth Carter, and we see the vehicle he owns. His car is an inexpensive vehicle. We also see the other involved party is James Long, who owns a Jaguar, which is a luxury car. On our network graph, we add additional connections such as the repair shop that did the work, and we see that the insurance contract was signed by Kenneth. We then view locations of these objects on a map, and we see that one party lives in San Francisco, the other party lives in Mountain View, and the accident happened in nearby San Jose, but both cars were serviced at a repair shop far away from those original locations. This is very suspicious. At this point, we'd like to document our findings, and for this we'll use DataWalk's storytelling facility. With this, we can easily take a screen snip, title this Suspicious Claims Associated with this Repair Shop, and add a comment of repair shop is far from the locations of both involved parties and the location of the accident. We can preview this to ensure it looks okay, and this becomes the first page of our story. During our investigation, we can then add additional pages as desired to create a visual, documented story that can be easily shared via DataWalk or as a PDF. Now we add other claims which are related with this repair shop, and as we extend our analysis, we see that the same adjuster was associated with several claims. When we load adjusters, we immediately see that adjuster Sean Owens handled these claims. We then load individuals, and then vehicles, and we see an interesting finding similar to what triggered this investigation. In every case, there was an accident involving a very inexpensive car and a luxury vehicle. Further, 3 of the 4 parties share the same phone number. Then by changing our view to a map, we see that all these accidents happened in the San Francisco Bay Area. With this evidence, we conclude that this may represent a fraud ring, such that we should hold claim payments, take action against an adjuster that may be involved with fraudulent claims, and forward this case to law enforcement. With this demo, we've shown that data from various sources can be easily integrated and analyzed, that hypotheses can quickly be tested, complex alerts can easily be set, claims can be scored, and cases can be efficiently investigated.